So in this video, it's a continuation of the previous video on what a geometric sequence is and finding terms of a geometric sequence. And today, in this video, we're going to focus a little bit more on writing recursive and explicit formulas. So we ended that last video and we had created this sequence right here, 64, 80, 100, 125. Now, we hadn't known, like we created this from a given, well, actually we created it from these first two terms. And we found that when we wanted to find our common ratio, or we want to see if it's a common ratio, we would do things like we would take what is 80 divided by 64? And the answer is 1.25. And if I take 100 divided by 80, the answer is 1.25. And if I take 125 and I divide by 100, I get 1.25. And we have that idea that when we divide any term by the term preceding it, we always get the same ratio. That's the idea of our common ratio, and that makes a sequence geometric. So we're trying to write this recursive formula. So all recursives, we always start with our A1, and in this case, A1 is 64. And then we have to think about, how do I get the next term? Well, I take the term before, and in this case, we multiply by 1.25. And we're going to do this for all n greater than 1. Again, that's not something that we're going to focus on, but you might see that later on. Now the question is, so this is our recursive. If I want this term right here, I take the term before, right? So this is A2. I want A2, I use A1, and I multiply by 1.25. When I want, say, A4, I'm going to multiply A3, which is 100 by 1.25, and that will give me A4. What will this look like explicitly? We can think about ways to write these things out. So if I think about I had 64, and then this number right here, the 80, that was 64 times 1.25. This was my A1. This was my A2. The next term was 100, which was 64 times 1.25 times another 1.25. I multiplied my common ratio again. So in other words, A3 was 64 times 1.25 squared. And the next number was 125, which was 64 times 1.25 squared, but then multiplied by another 1.25, which is 1.25 cubed. And in general, if I want the nth term, I'm going to take my first term and I'm going to multiply by my common ratio. How many times? Well, to get the second term, I multiplied by my common ratio once. To get the third term, I multiplied by my common ratio twice. To get the fourth term, I multiplied by my common ratio 3 times. So to get the nth term, I'm going to multiply by my common ratio n minus 1 many times, right? It's similar to our arithmetic, except instead of adding our common difference n minus 1 many times, we are multiplying our common ratio n minus 1 many times. And we have this idea that we're just thinking out. If I know the first term, it could be anything, not just our whatever we had as our first term. If I want to find the fifth term, I multiply my common ratio 4 times. And multiplying repeatedly is to the power. If I want the 50th term, I'm going to multiply my first term by my common ratio 4 times. And if I want the nth term, again, it's going to be, I'm going to multiply that by that ratio n minus 1 many times. And that gives us this super handy in general explicit formula. If I want the nth term, right, I'm going to take the first term, whatever that is, and multiply by my common ratio n minus 1 many times. And that's our general formula for a geometric sequence. This is a good one to write down. All geometric sequences, this is sort of the general explicit formula. It'll always work as long as you have the first number. If you have the zero term, you're going to multiply by the common ratio n many times, but that's a whole other ball of wax. Okay, so let's try a couple of problems. So I want to find the sequence formula for an. So again, you should be able to do recursive. If we do recursive here first, I think that's the easier one. We need our a1 is 8, and an is an minus 1. We're going to take whatever number we have, and we are going to multiply by -3. Okay, so that's recursive. If we are doing explicit, then we're going to take the nth term. We don't need to state what our first term is. It sort of becomes part of our formula. We're going to take our first term, and we are going to multiply by our common ratio n minus 1 many times. So then when I want to find the fourth term in that sequence, I would take 8, and I'm going to, so a4. I'm going to take 8, and I'm going to multiply by -3 cubed. And that would be 8 times -27. Doing this on my handy calculator. And I get -216. Right? The next term, if I wanted a 5, I would just multiply by -3 again. And I would get 648. This is going to, if we wrote these terms out, this is what would be called a alternating sequence, because our terms go back and forth from positive to negative, depending on whether my power is positive or negative. When n is an odd number, n minus 1 will be even. And when I raise -3 to an even power, I'll always get a positive. And when n is an even number, n minus 1 will be odd, and I'll multiply and get a positive. Okay, so I think we're going to skip this other one, and we're going to try one like this. So I want to find a formula for an, also for a8. So things I have to do here is I have to recognize that this is geometric. Generally, when I'm doing this, I always think arithmetic first. So I might say, how am I adding to get here? Well, I go up 15 to 0. So this would be plus 45. But if I add 45, there's no way I'm going to end up at -60. The fact that it's alternating makes it pretty clear it's not arithmetic. So geometric. So I need to find the common ratio. So again, I can do 30 over -15 and think about -60 over 30. And I could think about 120 over -60. And in each case, I get -2. That's my common ratio. And maybe you can just look at that and see that. That's fine. You can say, oh, I know, I'd multiply by -2. And then again, times -2. So what we know is that our common ratio is -2, and our first term is a8. So if we wanted to do this recursively, we would say a1 is -15, and the nth term is, our ratio is r times the n minus 1th term. If we want to do it explicitly, and again, to find a8, I would have to list out all my numbers, and that is somewhat tedious, although you can use the sequence mode in your calculator. But really, explicit is much more useful most of the time. So if we're doing our explicit equation, right, we are going to take our first term, and we are going to multiply by our common ratio, n minus 1 many times. Multiply. And when you multiply over and over by the same number, that's raising it to the power. So when I want to find the 8th term, I'm going to take -15, and I'm going to multiply by -2, basically to the 7th. Right? And I can, again, use my calculator. Parentheses are going to be super important here with that negative. I want to raise parentheses -2 to the 7th power. And I get 1920. If you don't have your parentheses, your calculator will do order of operations. It will raise it to the 7th, and then multiply by the negative, and that will not get us the correct answer. So one more, a little trickier maybe. This is one where it's harder to see, especially in the initial ones. But once you get here, right, what's happening on top, what's happening on bottom? And then I think about from here to here, what's happening on top, what's happening on bottom? And it looks like on top, I'm multiplying by 2. And on bottom, I am multiplying by 3, which means in general, my ratio is 2/3. Now, going backwards, does it make sense? Well, if I think about starting at 2 and I multiply by 2/3, that would get me 4/3. So that sort of makes sense. And then if I had 3 and I multiply by 2/3, see, this is where the trickiness shows up. I do end up at 2. So those initial numbers follow the pattern. They just weren't as hard to see it. And again, if you can't see it, you can always use your calculator, or you can just do the division, right? The easiest one is the next term right here, 2 divided by 3. That's my common ratio. And if I take 4/3 and I divide by 2, remember dividing by 2 is the same as multiplying by 1/2, because there's my 1. And this is, again, 2/3. Same ratio. When I'm getting the same ratio every time, that is a geometric. So now I have my common ratio. What I need to do is I want to write my, let's just go right to explicit. Hopefully you can do the recursive. So AN, take my first term, multiply by my common ratio to the n-1 many times. Because the second term is my ratio multiplied by my ratio 1 time. Right, when I want the second term, I've multiplied by the ratio once. When I want the third term, I've multiplied by my ratio twice. When I want the fourth term, I've multiplied by my ratio 3 times. And then again, to find A8, I can just do my formula. 8 minus 1 is going to be 2 to the 7th power. And I can use my calculator to do this. And it gives me this funky decimal. And sometimes you can do math fraction. And I get 128/79. Otherwise, I would try and write the exact decimal, which is like 0.1755. Yeah, it keeps going on, depending on how many things you want. But this is the exact answer, so this would probably be what we'd prefer. Math fraction is your friend. All right, this one's now gotten a little long, but hopefully you can now find the terms of a geometric sequence, write recursive and explicit formulas. I think that we are going to actually nix these this year. Given our distance learning, that's probably a little beyond what we want to do, but you should be able to do these other ones, hopefully. If you have questions, come to a Google Hangout.